class that we're going to talk about inheritance. I have a bunch of really cool examples where I see inheritance used most commonly. So in this first example, we're going to talk about diamond inheritance, where you have this structure where you have a parent and then you have children, but then you have a grandchild, which actually shares the same like grandparent as its two parents. So this is called diamond inheritance. Okay, so first take a second and look over this code and tell me, maybe turn to the person next to you and describe to them what you think the output of all of these size ofs will be. We have size of B, size of C, size of D. Yeah. Okay, go and chat for a second, see if you can understand what's going on here. Okay, I'm going to run it, so keep discussing while I go and set this up. Okay, I'm going to run it. All right. Did anyone guess that this would happen? Okay. Well, so if we look, right, so A has what member here? What variable, member variable? It has X. Yeah, okay. X, how many bytes is X? How many bytes is an integer? Yeah, it's going to be 4 bytes, at least on this machine. Yeah, okay, so it's going to be 4 bytes. So if B inherits from A, we should, and there's no extra member variables from B. So how many bytes do you expect B will be? Probably also 4, yeah, and it has the member variable X, and then C also inherits from A, so C will also probably have a size 4 because it also has an X. But then we have D, which if you notice, so it inherits from both B and C, okay? So that means that it actually, how many X variables does it have now? Well, yeah, it's like kind of confusing, right? Because it's like, well, the X came from the grandparent, but for some reason, like because we're inheriting B and C, actually what ends up happening is we duplicate this X, and now we actually have 2. So if I uncomment this line here, uncomment this display, which is causing me issues, and now print out the size of each one of these, oh, right, I just have to instead, I just won't print out X, that's fine. And I will also not print out any of that. Okay, so if we now look, yeah, so we can see that the size of B is 16. Wait. That's funny. Did I... Wait. Anyone know why this is happening? I'm actually kind of baffled by this. Why is the size of B 16? Anyone know? Yeah? Does the function declaration have memory? It should not have any. That's okay. I think maybe what's happening, I think what's happening is it's putting some padding on at the end. This is not something I've experimented too much with, inheritance and specifically, padding. Anyways, okay, so you can see that though the size of B is 16, but then the size of D is, the size of B plus C. So I assume it's just adding additional padding, and so in total there's 16 bytes for each of them, so in total now it becomes 32 bytes, which kind of sucks, right? Because we wanted it to just have probably just one X. Like we didn't expect it to have both. So this is actually a somewhat frequent problem. Yeah, so this is why I wanted to pull it up. This is called diamond inheritance. This is just a difficulty when you deal with inheritance. You generally don't want to ever have this structure, because when you have this structure, you end up creating unnecessary data. And now, we can't go and just print out what is inside of X. Let me go and print out, yeah, cool. Okay, so here I'm defining D, and if I do D.display here. So this d.display, this will run this function right here, which currently is not printing x. But then if I want, I can choose which display to run from the children. So I can choose to run B, or I can choose to run C. And similarly, up here inside of this function, I can choose to, I can't just do x, but I can do like C, like that, or I could do D, like that. So you can choose one or the other, but you can't do both. B or C. Yeah, so okay, let me run this just to prove it to you. Yeah, look at this. So there we go. So we can see, yeah, it's displaying from D here, which is this first thing, d.display. Then it does display from B, and then display from C. Okay, cool, okay. Yeah, in the case where you ever have to deal with this, now you know. So there is a syntax that allows you to grab like both sides from the things that you inherit from. Yeah, totally allowed, but definitely something to avoid. So popular, quiz question may be like, oh, like, why should you avoid diamond inheritance? And you might say, what? Well, probably it creates unnecessary memory. And also it maybe creates confusion in which of the two inheritances, which of the two parents are take precedence. There we go. Okay, hopefully you've all written that down. Great quiz question. By the way, this week has been pretty intense, like just information. You can imagine that there's probably going to be a longer quiz on Monday because there's going to be, we just covered so much stuff on inheritance. And even though I've kind of said inheritance isn't as popular nowadays as it used to be maybe 10 years ago, but inheritance is still an extremely important interview question that you will all face. And you will undoubtedly, if you're ever interviewing for some sort of software position, you'll be asked something about inheritance, abstract classes, interfaces, any one of these terms that I'm covering. So it's kind of just important to know all of this, because most likely what you're going to have to do is, if you remember from Wednesday, what was, in my opinion, the largest problem with inheritance? What is the biggest problem that creating this coupling between classes causes? What is the biggest problem? You remember? Yeah? You remember? Exactly, yeah, the refactoring. It's that if you want to add one little bit of functionality, now it affects everything else in your entire design. So when you are now a software engineer at Facebook and you need to restructure some of their code to run a little bit faster, you are going to be spending a lot of time going over legacy code and trying to understand all of the relationships between parent and children classes. So you're going to be spending a lot of time refactoring code, even though you probably won't be writing code bases from scratch that use inheritance as much. Yeah, question? Oh, I said that a reason why diamond inheritance is not very useful, or at least diamond inheritance is something that you should avoid, is because it creates unnecessary memory in the grandparent. And also, it is ambiguous to which avenue to access the grandparent, from which parent to access it from. Yeah. Cool. Okay. Diamond inheritance. Yeah. Okay. The next example that I wanted to move on to has any. Oh yeah. Question. Oh, you think? Oh, that's the vtable. I don't think that the vtable affects the size of command, but it could. Yeah. Sure. This is good information. I'll come back to that. That's a really good theory. Size of. I'm not sure. I think it might just be, yeah, I'll look into that, yeah. Yeah, another question? Oh, size of A would also be 16, yeah. Cool. Okay. Any musicians in here? Okay, cool. Anyone pull up a digital audio workstation from time to time and try and make some music? Yeah, okay, cool. Got like 2 people. If you are an artist or a musician or anything, great way to use your engineering skills for good is to find some sort of open source like artist, musician project and try to contribute to it. One thing that you could try doing is if there's a digital audio workstation, you could make like a plugin for that, or there are plugins for, I don't know if there's a plugin for like GIMP, the like art program, but probably. But oftentimes, you'll have to make plugins for your favorite applications, and oftentimes what the plugin interface may look like will use inheritance. So here, I want to show you this code. So take a second, look at it, and discuss with the person next to you. Go and explain to them what this code does, like what you would expect to happen. Yeah. Well, imagine that this is in like the examples folder of the Reaper plugin GitHub repo. Okay, so probably this class right here, this is going to be what is provided to you in maybe like a header file. And this plugin, this like plugin class, describes every function that you need to implement in order to create a valid plugin. And maybe this plugin, like maybe there's some sort of kernel inside of your application to where your application, like it runs a bunch of things, and then maybe after it's loaded all of the GUI and everything, then it starts running the program, or the plugins, where first it'll run like some initialization on all of the plugins, then it will begin processing them, like maybe this is in like a while loop, it's gonna like process, and then after, once you hit like the exit button, then it'll go through and start shutting down all of the plugins, make sure there's no like memory leaks or things. And then, it deletes all of the plugins. So the idea with this is, so plugin A and plugin B, maybe these are like custom plugins that you have written. So this is like, maybe this is Ethan's plugin or something. And then this is like someone else's plugin. Yeah, and all you have to do is, like, in order to make a valid plugin, is all you have to do is just implement these 3 functions. So you don't need to worry about anything else. Like, you don't need to necessarily worry about the inner workings of the application that you're working in. Instead, maybe they'll just tell you, like, oh, like, in order to run the program, or in order for your plugin to be like correctly loaded, these are the only 3 functions that you will need to implement. And then if you want, you can implement some more functions. So maybe you have like a do calculations method that performs some sort of like weird filter on something. But this is a totally reasonable interface that you may see if you were to create plugins. Let me quickly run this just to show you what it will look like. Okay, so I just ran it, and so there we go. So we can see that so we have this vector of all of our plugins, and so we do plugin A initialized, plugin B initialized, and then it starts processing plugin A, plugin B, and then it shuts down plugin A, plugin B. Okay, wait, by the way, what is these few lines of code an example of? So we have plugin A and plugin B. Okay, are plugin A and plugin B the same type? No, they're different types. But why are we able to put them all in the same vector? If they're different types, why can we put them in the same vector? Yes? Yeah, well, sure. Quite close. Well, we can put them in the same vector because they share the same base class. The base class is plugin. And then we can utilize polymorphism. Okay, do you remember the definition of polymorphism? Okay, hopefully you just look in your notes and you're like, oh, great, like I have it written down perfectly from on Wednesday. Okay, this is something that you should know. You should all write it down. Okay, I'll write it down all in front of you. So polymorphism. So in this case, we are experiencing polymorphism because even though we have casted plugin A and plugin B to the plugin type, they still behave like their intended functionality. So polymorphism is when an object is casted to another type but maintains its intended functionality. Yeah. So here, like we expect plugin A and plugin B to work as plugin A and plugin B, but we're casting them to plugins. And so here, when we run initialize, process, and shut down, it does indeed run as like plugin A and plugin B. So that is what polymorphism is. Okay, hopefully all of you have written that down. Okay. All right, cool. Okay, so which one's better? Yeah, okay, cool. So has anyone created their own programming language before? Okay, guys, a couple people. I'm certain that all of you in your careers at some point will write at least a couple programming languages, or maybe at least just a compiler or parser for a language. This happens all the time. Like even as a chip designer, like I've needed to write my own like languages. This is a fairly frequent thing. I mean, even I guess for this class, right? Like writing the assembler and things. Like I have to write. Yeah, it's just very common that you need to deal with code, and the way that you store code, like from a file, like after you've parsed out the file, is in something called an abstract syntax tree. So it's the abstract syntax tree. So syntax tree meaning like the code syntax, and it's a tree because it's like you have nodes. Like your top node is like has like all of your code, and then maybe the first element is like your main function, and then the next element are like your different like lines of code. So so a syntax tree. So that is the data structure that we use, and then it's abstract because usually there is some inheritance that is used. So every time that you run G++ or Python or really any sort of parser or language server, anytime there's some sort of inheritance that's happening behind the scenes. So I wanted to briefly show you an example of what happens when you have a program that parses out your language. So here I have ast.hpp. I'm going to switch sides, actually. All right, cool. So you can see as my top class, I have expr, which stands for expression. And this denotes every single node that will be inside of my tree. And then this expression, note that it can either be, in this case, it can either be a number or it can be a binary operation. Binary operation meaning it takes in two values. So like A plus B, like A and B, those are like two values, A minus B, anything that takes in two values. And so here, it's a very, very simple language, but we can see, so in our main over here, this denotes what will be inside of our abstract syntax tree, which you can see will have this expression right here, where we have like 3 and 2, which are multiplied together and put inside of this binary operation class. And then we also have this number class. And so this number, which is 5, is added with this binary operation, which is performing the multiplication, and then that is all added together. So okay, so if I now run this, so yeah, note that like this code, like if you imagine like maybe this came from a file first, or we could imagine that it could come from some like parser. Maybe parser gives us some expression object instead of just kind of hard-coded it. But yeah, maybe this object could come from a parser. And then now we can perform some sort of simplification on this later. So let me go and run this. Come on. AST, okay. Plus plus. Okay, so there we go. So we can see that we have successfully converted this kind of all these pointers in this big tree that I have hard-coded right here. We have converted it out into this like nice kind of neat method right here. And yeah, maybe what you could imagine is maybe this would be like if you go from a C function and then maybe you compile it and then you export it now as assembly, because that is something you can do. Has anyone done this before? You're generating some. Wait, let me quickly show you that. Usually I think I would have shown it by now, but let me quickly show you. I believe you do -s. Is this what you do? I think. -s? Is that right? Yeah, there we go. Cool. So I just compiled it with -s, and I've now used G++ to actually export all of the assembly that was like inferred from this main file. This is kind of cool. So yeah, and if you've ever like been interested in like what is the actual assembly that is being generated from your code, that is how you do it. You do G++ -s. There we go. So yeah, we could scroll through. We can see all these x86 instructions. It's kind of pain. I won't go through this massive file. Just this very basic program has almost 4,000 lines of code. So but feel free to go through it in your own time. Anyways, okay. So yeah, so we can imagine that maybe like G++ has some sort of print method right here that their abstract syntax tree will have, and print maybe prints it out as assembly or something. In this case, yeah, so I'm just printing out just the values. There we go. So now I want you to think for a minute. Think how we could potentially add like a simplify method to where, like, notice like I'm adding in all these like hard-coded values. Like I'm adding in 5 plus 3 times 2. So we should imagine that this should just evaluate out to 11 if we had like a well-designed compiler. Like it would just take in this value and wouldn't perform this computation at runtime. Instead, maybe it would simplify it all as soon as it read it in. So maybe think about what is the best way now to do that for this implementation. So how can we add a simplify function to this while still taking advantage of inheritance? So okay, go and chat for a couple minutes and come up with an idea of how we can put a simplify function into this. Can you hear me? Good. Okay. Yeah, any thoughts? Let's just kind of chat about this. So maybe like an obvious kind of idea would be, well, maybe we just have some sort of like helper function that like is outside of this. Maybe it's some other class. It's like a simplifier class or something, and it looks at every node. It's like, well, if it's a number, then it's simplified or something. Like, yeah, I don't know. Did anyone kind of think of doing it this way? Having like a whole separate class kind of go through this? No? Okay. Yeah, I don't know. What's another strategy that someone was thinking? Anyone? How do we add a simplifier function? Yeah. Uh-huh. Sure, okay. So create another function that takes in two values and then performs that computation and then returns the value, and then I guess, yeah, once it goes through all the values, maybe finish. Okay. I like that. I think we can take more advantage of our class structure, though. I don't think we need necessarily a function that takes in two values. Like, look here, like we have left and right here. So maybe in this binary op, maybe we have something that will, maybe have like void simplify. Simplify. Yeah. Okay. Any other thoughts? Maybe let's get a few more ideas going. Anyone? Yeah. Well, one thing that I'm thinking like right off the bat is probably we should have a simplify method probably on the top level, and that forces now every single node to have some sort of simplify method. So maybe we can have probably another pure virtual function that requires implementation on all levels. Simplify. Okay, there we go. So now even number will need the simplify method. Okay. And probably shouldn't be const. Okay. Well, in this case, we probably don't need to do anything to this value. Like it's already kind of done. So we could probably just not do anything. Okay. And let's go in and run simplify over here. Okay, oops. Okay, so currently, we have two empty simplify functions. What can we put inside of maybe this simplify function? Yeah. Right, okay, yeah, I like that. So maybe first we simplify the left-hand side and then we simplify the right-hand side. So yeah, maybe left, simplify, and then right simplify. Okay, yeah, I really like that. And then maybe after that, then we like kind of perform the computation in some way. And maybe let's just consider, maybe for now we can just pretend like we only have additions or something. So we could say, int result equals, we could say left, and notice that left is also an expression. So we would probably need to like grab its value. So maybe instead of just simplify, maybe add another method here that is like get value. Okay, this could probably also be const. Okay, so for get value now, for number, what would this be? What will go inside of here? Yep, shout it out. Okay, return value. Sure. No, this should probably be int. Yeah, totally right. Okay, cool. Good. Yeah, so here we're adding these pure virtual functions, which are going to help. So yes, we have this get value. Cool. Good. And get value on there. And so maybe get value now. So we say, yeah, simplify, and then we say left and get value. And maybe we say the result is the left value plus the right value. Okay, sure. And maybe we have this be get value instead. Sure. I was thinking of making it a little bit more complex, but I think this is totally fine. Yeah. So return result now. This is int and const. There we go. So from this now, maybe instead of simplify, now we can print out the value. And then maybe we could have some other kind of thing that passes through. Maybe the simplify function, what it will do is once it runs get value, maybe what it will do is it will swap it out for, from a binary op, it will now swap it out for a number instead. And so by using inheritance, by using this interface right here with print and simplify and get value, we've now forced onto every member to now to support this simplify and get value method. And that is something that you'll see anytime, that you pull up any sort of abstract syntax tree implementation in any way. If you are no matter what language you're dealing with is most likely going to have these three methods and maybe a few more to help simplify it even further. Yeah, cool. Any questions on this? We can come back to this. I have another example that I want to show, but yeah, any other questions? I guess I can run it. That'd probably be good. So let me run this. So get value. Okay, so we can see that I'm creating the tree first, and then I run this get value function. And this is only possible because, with inheritance, I'm able to get the value of the numbers, but I'm also able to get the value of the binary operation. Okay, go. What's going on? Yes. I think I'm not overwriting things. Actually, this is another good thing. So, okay, here in the starter code, notice that I have this keyword override. Has anyone seen this before? Okay, so another common kind of thing that I'd like to talk about more as this class proceeds is a common strategy that people use is to move runtime errors out of runtime and moving them into the compile time. So that's what this override keyword will do. So here, so override is saying this function exists in order to be this function exists to override a virtual method. So yeah, you can see this print, you can see it's overriding this virtual method, so I've put this override method, I've put this override keyword. So I should probably do that for actually all of my methods here. And it's not required, but it helps put out compiler warnings. Yeah, so here we can see we actually get a compiler warning because notice it says that it's not properly overriding anything. But that's weird, right? Because number, it very clearly, it looks like we should be overriding get value. What is the issue here? Yeah? Yeah, exactly. I've missed a const. So therefore, it looks like it didn't actually know that this was a function. So there we go. Okay. And then now, yep, get value. We can make that override as well. And then finally, we need to add simplify, which at the moment I'm just leaving as stub. Actually, I'll just remove it because that's fine. Okay. All right. And we can remove this as well now. Yeah, that's fine. Okay. Cool. There we go. So from all that, get value. Wait, what? I'm not even running print. Wait, does anyone know what's going on? Yeah? Oh, I'm sorry. I'm still generating the assembly. That's funny. Okay. Cool. Okay, there we go. Great. Except it's 10 for some reason. Anyways, that's fine. I think we've spent enough time on this. Why is it 10? Anyone know? Oh, because I'm only doing plus. I'm not handling the multiplication. Yep. There we go. Cool. Yeah. So this is great because I'm able to have this tree where every node, like I could have numbers, I could have binary operations, I could have if statements, I could have arrays, like I can have any sort of entry into this table that I would like. And that's all possible because I have this base class of expression. Cool. And yeah, in an expression, this is where you say like all of the things that are required from your interface. Cool. Okay. I have one more example planned. And then we will move on to talking about the final project, I think. Okay, cool. Good. So this example right here, this is the final example. This is something that I see all the time as well. This problem right here represents a crossroads of potential paths to take, and one of them is like the incorrect way of applying inheritance. One of them is the correct way of applying inheritance. So if we look at this, so here we have this database source class, and then here we have this file source class. And the idea with this, so we have the database source class, and we have this function get fancy data, and maybe get fancy data, like maybe this runs like some like complicated database fetch and whatever, HTTP things and sockets, and it's like very complicated. And after like 5 minutes of executing, maybe finally it returns number 42. So that's what this one class does, database source. Versus over here, you can see that the data, instead of get fancy data, instead of this method, instead we just have the data maybe just initialized when we read in some file at the beginning, and it's like much simpler to get this. But notice that the structure of these two classes are very similar. So here we have data, and then here we have get fancy data. So both of them have data, but then also both of them have this process data function. And the idea with this process data function is that, notice they are actually identical, excluding just when it calls this data. So in the file source, it calls it from this like in data equals 75, but here it grabs it from this function. But notice like the processing is still the same, it's still +3, and it still prints out the same data, and it's like the same comments. Like these functions are like, they should be exactly equivalent, but what happened is just like a slight variation on how we're getting the data. So the question now is, if you notice, like both of these share this process data function. So I would say that there's kind of two strategies that we can apply inheritance to simplify this code in order to reduce code duplication. Because yeah, like ideally, like if I come along and if I'm like, oh, like actually I want to be adding 6 here, I need to like just remember that actually I need to add like 6 in all places. So it'd be nicer if instead we had maybe like one single process data function that could do everything. So okay, what is a solution to this? How can we make this code drier? Yeah. Okay, so we have another function that calls process data with different inputs. Okay, I kind of like that. Ignore this. Okay, what about if we do, what if we do this? What if we do, so here's data source and file source. What if instead we made a class that was like, data process. And maybe this is just an interface where we say virtual, and then it takes this virtual void process data, right, equals 0. And now both of these classes inherit from this. Okay, so this is oftentimes a lot of people's gut reaction to seeing 2 classes with the exact same function name in them. But why does this not actually like fix any problems? Because like it seems good in a way, right? Because if we think back to the last example is we needed every class to implement like all of them needed a simplify method and a print method. They all needed that. In the same way that in these 2 classes, both of them need this process data method. So therefore, like it looks like maybe we should have this interface process data to like just really enforce that these classes must have this. So why does this not actually fix anything? Yeah. Sure. So you're saying in data process have a variable like int data or something? Yeah. You could do this as well. But maybe you don't actually want to use this because notice like here we don't actually have a data like member variable. Instead we just have get fancy data. So the way of accessing this data is unique to every class. Behind. Yeah. Yeah, exactly, right? You still have duplicated code because the implementation of process data is actually like exactly the same. Like the actual implementation is exactly the same. So the idea with interfaces is that when you have an interface like this that you inherit from, the idea is that every class that implements the interface, like implements this pure virtual function, it should all be like super disjoint and unique from one another. But here, like the process data function is actually extremely similar to one another. So instead of doing this data process like class like this, maybe what would be better is actually just like pass in this entire class itself. Actually, okay, before I get to that. So maybe instead of doing this data process, maybe instead we do a data source class where we have this get data method. And so now this data process will now inherit from data source, and then now we can implement this get data method inside of here. So now here, this would probably return get fancy data. And then here, what would this implementation of get data look like in file source? Yeah, probably return data. Okay, I think this should be const. Okay, well now, there we go. So now we've actually created a much more probably useful interface here. Now we have this get data method. So now we could probably make some other class that implements processed data and takes in the get data method. So there we go. Okay, so we can probably make a data class data processor. Okay, and this will probably take in process data. And maybe we could pass in as the value, we could pass in an integer that is the data. But okay, actually, yeah, so let's do this now. Actually, maybe this is a good example of why maybe we wouldn't want to do this. But yeah, but now notice, because we have this other class, now we can actually get rid of these implementations here. So now look at our database source class. It's way simpler. Now instead of boilerplate, now it's all kind of valuable information. Now we have our actual implementation here, and then we have get data, which determines what the most important data is. And here we have get data, which returns the data. So now this get data method is actually our true source code, and now we have this process data class up here, which is useful for everything. So and then I can make this public really quick. Okay, and now instead of process data and process data like this, then now we could probably do something like data processor. And I also, I'm going to make this static. Okay, we'll talk about static in a second. Anyone seen static before? Static, okay. Think about why I'm doing static here. So data processor, and the way that you call static functions is you do : : So now I'm going to call process data. And now I can pass in database source dot get data. And file source dot get data. So there we go. So the entire purpose of this, we've added a little bit more code now, but the most important thing is now our data processor class. This is the thing that actually processes the data, and now it's no longer forced onto these database source and file source classes right here. Yeah, kind of cool. Okay, let me run this. Good. CD dependency injection. Okay, there we go. So we can see that, in fact, we have processed the database source correctly. We are printing out just this data. I guess what I had last time, was +3 on both of them. So we can add that +3 back. But yeah, we can see that it first prints out this 42 data, then it prints out the 75. Okay. Well, now another question to you, really quick. So this .get data thing, it's a little bit redundant because it's very clear, it's saying oh, we're going to process the data inside of this. So maybe we don't want to pass in I don't know. Yeah, it's just a little bit gross to have this .get data. Maybe instead it would be nicer to just have this, right? Instead of passing in .get data, because it's kind of implied, right? So okay, how could we now modify our code to now make it work with this structure? Okay. Yeah? Sure. Yeah, so maybe instead of int data, what do you think we could take in instead? Yeah, it would be data source, because data source has get data. So now we can pass in data source, And I think we probably want a pointer, so we can call this data source. Okay, and then now instead of data, it will be data source, then what? Yeah, data source, get data. There we go. Okay, and now here, you know what, and actually let me not make it a pointer for now. Let me just make it a const reference. Okay, yeah, this is fine, okay. So now we can run this, and hopefully this will fix it. So notice that database source, like we're passing in database source, which is a type data source here, into process data. Process data expects the database source, so this should work, right? Okay. Any reservations? Should work? Should not work? Should work? Would you bet like 50% of your grade on it? Would it work? Not work? Okay. I don't think it's going to work. Why is it not going to work, though? Okay, let's test it. Okay. Oh, wait. Is it because... Okay, why is this not working? I'll zoom out just a hair so you can see everything. So we initialize it here. That's what this bracket right there is denoting, is we're calling the default constructor on it. Yeah. I think that might be what the... Oh, okay, there we go. Sure, cool. That, I thought we were going to get a different error. Okay, cool, there we go. Totally right. Yeah, so the issue is, note that I left off public here. Public, this determines what is allowed to be looked at from the child class. The child class, like, it doesn't by default have access to everything inside of the parent class. So you have to specify like what permissions you grant it. Yeah, there we go. Cool. Yeah, and back. Exactly, yeah. So it's trying to access a private variable. Like right here, when we try to access .getData, since getData is from the parent, then getData, like we need to specify the privilege on this. So we're allowed to access getData inside of our inside of our implementation. But anything that then calls our, like you can think of it as like, it's now private. Yeah, you can think of get data as being private now, like over here, if we get rid of this public. If that makes sense, yeah. So if we don't specify it as public, then now all of the parent functions will be considered private. Yeah. Process data. Oh, so why don't we put the data process class into this? Oh, so yeah, the question was why don't we put this process data function into this get data? Well, the issue with that is that now, I guess with this current implementation we could, but the potential issue is that now it grants access to process data in all of these children. And we don't necessarily want that. It might actually work in this case. Let me see if I can think of a better answer to that question. Yeah. Maybe let's all spend a second and chat with the person next to you. Can anyone think of a reason, like an organizational reason, why someone would not want to just put this process data class into data source? Yeah. I know that there is a reason. I'm kind of blanking on something right now. Yeah, I don't know. Okay, anyone have any thoughts? I have a couple thoughts. Yeah.
I would say in this specific example, I wouldn't even put the function inside of the class. I would just make it its own function. There's no point to put it in the class. But in a more complex example, data processor could have internal state that's needed to process stuff, and you don't want to couple that with the source. That would be a case where you want that function in its own class.
I completely agree with that. That's what I was thinking as well. So this, let me restate that. So yeah, maybe this process data function, maybe this has some sort of internal state, or maybe this data processor, maybe this has some internal state. Maybe it's loading a file, or maybe it's trying to access data. It's doing something on its own, and maybe this process data function will update that state. And remember, anytime that we inherit from something, it means that we are forced to receive all of the members. And so if we wanted to inherit from data processor, like if we just combined these two classes, then now we are forced to also have all of the member variables associated with whatever state that process data has. Yeah. I completely agree with that. Yeah. In this case, it's probably fine. Yeah, and then something that was also brought up is maybe we don't actually even need this process data to be in the data processor class. Maybe this could just exist as its own kind of like global function like this. And that's okay. We could do it outside like this. But that's more of a C style way of writing code. The more C++ way of thinking about code is just putting everything inside of a class, even if it's not actually used as a class. It's better to just leave it as a class and just have a bunch of static members than to just have floating functions like this. And a big reason for that, I would say, is for namespaces, or if you ever do decide that you want to just throw on extra state or something. I feel like classes are more often used than C++ namespaces. Anyone heard of namespaces? We'll talk about namespaces later. But yeah, okay. Any other questions with this? I'm open also to any questions on the final project. I had several teams come to my office hours. My office hours are Thursdays from 3 to 4 online. I had several teams finish Hello World 1, 2, and 3 right before my eyes. So congrats to all the teams. It seems like everyone's doing a really great job finishing everything. I'm extremely impressed. You all have gone a lot faster than the last course offering. So really fantastic job with everything. If you have any questions, please ask them as soon as possible, though, on Piazza. I'm assuming that the TAs don't want to be answering questions all weekend. So if you're saving anything for the last minute, please don't. Please start asking questions right away. If you see someone post a question on Piazza and you think you know the answer, please give an answer. That would be super helpful. Having just more and more discussion, that just helps a lot. If you found an extremely challenging bug that you want to help other students debug, then you maybe just make a Piazza post. Be like, hey, I don't need help, but this is just an interesting thing that I found that maybe will help other people. Yeah. Any questions on anything? Okay. Yeah, question. I am not. Wait, where? You're saying this one? Oh, this is a reference. And the reason for this, yeah, why is const reference good in general? Sure, that's what const means, is you can't change the data. But const reference is important. I gave a whole demonstration. It is generally way faster and takes up less memory. So just by default, no matter what, you should just have as muscle memory, just always pass everything by const reference into functions. Yeah, I'm happy to explain more on that. Yeah. Okay, well, congratulations. You're all now experts on inheritance and polymorphism. And next week, we're going to talk about third-party libraries and debugging and all sorts of other exciting things. So get ready for that. Okay, see you on Monday.